Well, hello everyone, and welcome to today's webinar, ESRI Applications in the AWS Cloud. Before we get started today, I want to mention a few features of our On24 webinar platform. You will have the option of displaying, hiding, or changing the size of the items on the screen that you see right now. If you would like to, say, hide something like the speaker bios, just please click on the icon at the bottom of your screen, and it will hide that box. Also, if you're trying to expand any of the components, you can just click the green box in the upper right-hand corner of any of the components. And then also you can grab that box and move it around the screen to wherever you would like for the rest of the webinar. Also, you can also see some additional icons at the bottom of the screen. If you mouse over those, you can see other options such as downloading the slides, which you can do at any time. We will be taking questions and addressing those questions throughout the entire presentation, so please feel free to submit those at any time. With that, let's get started. I'd like to introduce our three speakers today. From AWS, we have Mark Ryland. Mark is the Chief Solutions Architect for AWS's worldwide public sector team. From ESRI, we have Marwa Mabrouk. Marwa is a product manager from ESRI that focuses on their cloud offerings. And today our customer presenter is Sean Kingsbury. Sean is the CIO of the Recovery, Accountability, and Transparency Board, and he will be talking specifically about their use of ESRI in their web property, recovery.gov. If you'd like to learn more about any of those speakers, again, please note the speaker bio box on the left-hand side of your screen. You can read about the details of all of our speakers. So to keep things interactive today, what I'd like to do is move into a couple questions that we have. We'll be sharing the answers to these questions directly after you answer, and all of the answers that you put in will be anonymous to the rest of the audience when we share them. So in terms of the first question here, we're just looking, and often others want to know what their peers are doing. So we're looking at what applications are you currently running or planning to run in the next 12 months in the cloud. So if you could just take a minute, you can select as many of those as are applicable to your use. When you're done, just click the Submit Answer button, and we'll probably just take about 10 or 15 seconds on each of these questions. So again, going through these, it's really public-facing websites and mobile apps, disaster recovery, archive, business apps, big data apps, and high-performance computing apps. Great. And so push here are the results of what everyone's looking at right now. So as you can see, public-facing websites and mobile apps, and then also really internal business apps are some of the leading ones, but big data and all of these are seeing significant use. Or at least potential use in the next 12 months. And so one that's more GIS specific, this will actually help us in today's webinar to sort of talk about the topics that are most relevant to you and the use cases that are most relevant to you. Again, select as many as apply here, but we have community engagement, operational awareness, asset and data management, planning and analysis, data backup and archive, and development. Okay, great. We see that most people are responding. Thanks so much. So this is really where most people are looking for GIS right now in terms of running it in the cloud with asset data management and planning analysis really leading, followed by community engagement. So that's great. And Sean, specifically, his use will be talking a lot about how they're engaging their constituents through recovery.gov with their ESRI application. And then our last question today is also to really help us tailor. Our presenters have a really wide range of expertise, and while we have the slides today, we can spend more or less time on different topics. And we want to make sure that we're covering the main things that the audience is looking to learn out of this webinar. So things like, why should my organization use GIS if you're really just starting to consider GIS, or if you're looking specifically at ESRI applications, really why those should be run in the cloud. Also, who's already running ESRI apps in the cloud, or if you're really looking more from the design or development, and from development we really mean actually like writing the code, or also if you already have the code for an ESI solution complete, how would you actually deploy that on the AWS cloud? So in terms of the responses that are coming through, we have lots around architecture. We'll definitely be covering that a little bit later in the presentation. And in terms of deployment of the ESRI solution, that's something that we'll cover more based off this response. So we'll have Mark from AWS talk a little bit more about how they can actually deploy the solutions that they already have running, that they're already looking to run on AWS. With that, I'm going to have Marwa come in and talk very briefly about GIS and getting into ESRI and ESRI applications overall. Thanks, Marwa.
Thank you, Reed. Good morning, everyone. So Geographic Information Systems allows its users to think spatially, to visualize their data and do spatial analysis. Through one look to a map, you can recognize a hotspot or quick information that maybe just looking at the data wasn't revealing. This type of bringing the data to life by looking at it in a map, this type of activity allows you to relate your data and analyze it in special ways that were not possible before. Esri is the world leader in GIS. In 2011, the revenues were nearly $1 billion. We have 350,000 customers in organizations around the world, and our customers run in all sorts of different industries. So what does Esri software help you do? The Esri software will help you with planning and analysis. Planning analysis allows you to understand your data, allows you to set comprehensive spatial analysis tools, utilize them, leverage that capability to bring relationships between the data that you're looking at. There's also a good platform of reviewing and disseminating your results by using the Esri software. Which brings me to asset and data management. Asset and data management allows you to analyze your own data, create your own data, check for its integrity, cross-reference that with data that Esri is making available online through a wide range of data sets that allows you to view topology, elevation, and other types of data, cross-reference your data with that, make sure your data integrity is contact. And also, Esri offers industry standard templates that helps your organization set their information standards, understand that and leverage it rather than think about it from scratch. Through operational awareness, Esri has a wide range of capabilities and developers' APIs that allows users to build their own web-based applications, to leverage the type of information to provide analysis and alert tools for the different users of the applications. These capabilities range and enable large volumes of data that are distributed over different parts of the internet possibly. Which brings me to the field workforce, which integrates with that by enabling users who are mobile, giving them the tools, the applications, and the APIs for developers that allow them to build their own type of mobile capabilities that integrate back with the type of operations that are happening back in the office. And through this type of capabilities and integration, users are able to share data, collaborate on certain problem solving, and achieve the results they are aiming for. Community engagement is another important aspect where through community engagement, certain applications can create localized views of their own community and engage the different people within this community to share information and to provide collaborative environments for them. So other users look for Amazon Web Services to provide different type of capabilities. This includes access to unlimited computing power through the cloud. Users are able to identify what resources are needed, leverage them when they need it. They can also create elastic websites. This elasticity enables them to support high volume type of access to their websites that can come in an unexpected way and be able to respond to that efficiently as needed. Also, ideal environments for developers who want to test new environments, test new setups, maybe plan for a migration. through the cloud, they can identify these resources and start using it without affecting their original platform that they are running on. And within all of this environment, users are able to leverage cost effectiveness by using the resources when they need it and letting them go when they don't need it. So Esri provides specifically for the Amazon Web Services Cloud 2 products, ArcGIS for Server on Amazon Web Services, which was launched in 2010. Through this product, Esri provides a number of Amazon machine images. Using these Amazon machine images, users are able to start their own instances in the Amazon cloud, and these instances would contain ArcGIS software already set up and ready to use. And then they start using it to build their own applications or to deploy their own data and content. Also, Esri Managed Services is another capability an offering that Esri has. It allows Esri to manage hosting as well as running the application along with the Esri software on its users' behalf. So within this capability, users would provide their application and their data, and Esri would host it and provide it to the public or to a specific audience as needed.
Hello, everyone. This is Mark Ryland with Amazon Web Services. So Marwa gave a great introduction to some of the powerful solutions that you can build with the ESRI software. Now we want to move to talk a little bit about the plumbing that enables that powerful capability using the Amazon Cloud Platform. Everyone who's built and managed and run information technology systems knows that there's a tremendous amount of work involved in just keeping the lights on, as Gardner says in the quote at the bottom of your screen. There's all kinds of planning, build out, lots of large capital expenditures to buy the equipment. You must maintain and run data centers. There's just a large number of operations and management requirements for anyone running these systems. The problem is that this is typically undifferentiated work that you do. There's nothing in the work that you're doing to build and maintain these underlying systems that really adds unique value for your mission or your business objectives. So one of the key advantages of the cloud model is to try to take that undifferentiated work that you do to build and run your IT systems and move those into an environment in which a highly automated system will enable you to deploy very quickly, run your systems, shut down when they're not needed, and pay it for only what you use. So when we talk about the value proposition for the cloud, we really bring it out into these 6 categories. Some of these I've mentioned already, and we'll go through these briefly. Well, first of all, a key advantage is no upfront capital expenses. You don't have to buy a bunch of equipment or buy a bunch of software licenses necessarily to begin building and running systems in the cloud. The overall cost of these systems can be much lower, partly as a result of the large economies of scale that the cloud provider, that Amazon is able to pass on to you, extremely efficient purchasing of power, equipment, internet connectivity, and so forth, but also because of your ability to scale your usage to be exactly what you need, to not over-provision and pay for things that you're not using, or to be under-provision, which is, of course, a disaster in the sense that you won't be able to fulfill your mission. Pay for what you use is another element of that. You can start a system and run it. When you're not using it, you can shut it down. You can also run systems in parallel. So you pay for 100 servers for an hour will cost you the same as 1 server for 100 hours. So you have a lot more flexibility and choice in terms of your deployment models. Self-service infrastructure is key here. Both your IT professionals and your software developers will be able to essentially build and manage their own infrastructure with a few clicks of a mouse or a few shell scripts. All of these systems are highly automated and available through programming interfaces, APIs. So there's really nothing that can't be done from software. And in addition, there's some graphical consoles that enable you to do this very, very easily as well. Scale up and down, mentioned already. This is a critical capability of a cloud platform, which we'll talk about further as we go through the presentation. And really, perhaps the most important value proposition for cloud computing is agility. Agility means that you can make changes and you can plan more quickly, you can begin to implement, and you can change your plans much more rapidly, learn from your experience, do what's called fail fast, which is try something, and if it doesn't work, do something else. And all of these things lead to much increased velocity of time to market, meaning time to mission completion, to operational systems that meet the requirements that your agency constituents and stakeholders need or your business requires. Gartner did a Magic Quadrant analysis of public cloud infrastructure in the recent past. This was late last year. And after analyzing lots of different elements of both kind of hosting capabilities and what I would call true cloud capabilities, we were very pleased to see Amazon come out as the upper right dot on this rather small little illustration here. By the way, Gartner is very, very cautious about these quadrants, so we can't modify it in any way, which is one reason why it's rather small and difficult to read. But you can download the presentation if it's not clear enough on your screen, and you can look at all the different providers that they analyze there. Amazon is also very proud to be able to show lots of different customers. We have a huge number of customers. Of course, many are private and don't permit us to show their logos on slides like this. But when we earn the trust of many of these customers, as we have for huge numbers, they enable us to put up a slide like this, in which they will publicly validate their use of our platform. And you can see here a large number of multinational companies, of government agencies, of ISVs, of end user companies, giving you just some sense of the breadth and depth of the customer base that we are able to support on the Amazon Cloud Platform. Now let's get a little bit into the scale of the infrastructure and the ability to support workloads on a worldwide basis. What you see illustrated here is our 8 regions. I'll describe in a moment what a region is, but think of it as a locus of cloud capabilities, and also edge locations, which means that some of our services, notably our CloudFront, which is a content delivery network, and also our DNS service, those are provided on an even broader basis to edge locations around the world. The regions are illustrated with the orange boxes. A region is really a set of data centers you can think of. We call them availability zones. That's kind of the logical model in what you see in our console. But it's a set of independently run and operated data centers that have very different failure characteristics so that you can be much more assured of your workloads staying operational. Even the very best industry practices still, no matter what all the providers do, there's still the possibility of failures, including failures at a very high level, such as some data center not available for some period of time. So to make it possible for our customers to build highly, highly available applications, we actually strongly recommend that you balance your workloads across data centers or availability zones within a given region. These regions are a network of data centers that are highly connected with high-speed networking among the data centers. This enables certain types of storage operations and platforms, notably our S3 storage service, which we'll talk about, to automatically replicate data among the availability zones so that when you do a write operation to the S3 storage system, it will automatically be copied amongst multiple data centers. However, we do not automatically copy across data centers across regions. And this is also critically important because it gives you control over data locality. So if you are operating, for example, in our European region, which is based in the Dublin area, There will be replication automatically within the region, but your data will never leave that region except under your own control. Amazon will not automatically replicate your data or in any way cause it to migrate from that region. So that's a critical capability, both the reliability within a region, but also the ability to think of these regions as essentially distinct clouds, and you control over which clouds that you use. Obviously, when people move to the cloud, security is a top priority. It's a new level of abstraction, and you can't go and touch and feel your servers anymore. So there's a very natural concern about what's going on. How do I know that? What are my assurances for keeping and running secure environments on these platforms? So for Amazon, this is really our top priority. We are able to satisfy our customer requirements through both lots of operational capabilities, perhaps even almost more importantly from a confidence perspective is the third-party certifications. So you don't have to simply trust Amazon when we say something is secure. You can look at our certifications by third parties. So for example, for U.S. government customers, we operate a number of systems that are running under the FSMA moderate level, and we're also involved in a sort of platform level certification at the FSMA moderate level right now with the General Services Administration. We also provide a special region in the U.S. West area that we call GovCloud. This is a region which operates under ITAR compliant controls, meaning it's U.S. persons only, and enables certain types of workloads that require restricted access to data. Data should be accessible only by U.S. persons. So Amazon operates on a U.S. persons basis. We have third-party auditors for that ITAR compliance on a twice-a-year basis. And customers, this is also very critical, customers who come into this region are different from our other regions in that you can't simply swipe a credit card and get access. You have to come to us and be vetted, and we check the customer's compliance through some available databases, which allow us to search for entities that have had any ITAR problems in the past. And in addition, you sign a special agreement for GovCloud, a contract addendum, in which the customer promises to operate under this ITAR regime. So the net effect of that is a very secure cloud, a kind of community cloud, if you will, in which either government agencies or vendors supporting those agencies are the sole occupants. We also have HIPAA certification of applications on our platform, and the platform itself has been certified by the credit card industry at its highest level. That's the PCI DSS Level 1. Finally, we have these more generic reports that come both from an auditing agency for the SOC 1 report and the ISO 27000 controls, which is another regime under which we operate. So essentially, all of our regions operate under a rich compliance matrix, control matrix, which is really a union of all the controls of all these different compliance regimes that are described on this slide. And of course, on the more practical side, in addition to assurances by third parties, we're very, very focused on security in a very practical sense with rich physical security infrastructure and also software and network change management, deployment that is very carefully controlled and monitored. We do safe decommissioning of all storage. So, for example, hard disks do not leave our facilities without not only degaussing but physical destruction. And we have a very rich set of monitoring and continuous monitoring tools in order to operate such large-scale systems in a very efficient and automated fashion. Customers run a variety of workloads on our platform. I won't dwell on this, but you can see, the general categories where we find lots of new deployments and new capabilities being brought onto the cloud. Everything from enterprise applications, working with lots of our software partners, web applications. We have a big interest in big data and high-performance computing. This workload is very, very amenable to the ability to scale up and down. So, for example, often a Hadoop cluster will be very busy on a Wednesday afternoon, and no one will be using it on Sunday. And if you deploy on premises, you're paying for a system that's sort of under-provisioned in the middle of the week and over-provisioned on the weekends, where in the cloud environment, each work group essentially gets its own cluster, runs it when it's needed, shuts it down when it's not needed. And it's a very extremely efficient use of resources, and we see a tremendous uptake of the cloud platform for big data and high-performance computing. And, of course, disaster recovery, archive, and continuous operations is a great workload for the cloud, especially since you can spread out to multiple data centers in multiple regions across the country or around the world.
Okay, my name is Sean Kingsbury. I'm the CIO for the Recovery Accountability and Transparency Board. We were created as the signing of the American Recovery and Reinvestment Act of 2009. Our goal is our mission is in two-part. One of which is to provide transparency to show the American public where stimulus dollars are actually going. In parallel, we have the responsibility for tracking fraud, waste, and abuse. So, and with that, we had to launch a website that could actually show the public where the money's going. So as of February 2009, we launched what we call version 1.0 of Recovery.gov. And again, that was we were under, I guess you can say, different requirements than a lot of other federal organizations because by law we had to meet specific dates for us to get things done. So we literally had to have a website up as of February 2009 to begin to start communicating this information. So at that point it was more of a flat website where we provided PDF documents and began to communicate. So what we did is we did a redeployment of Recovery.gov, which launched in September, and to meet a variety of other requirements, we were under tremendous constraints, and the majority of our constraints were actually time. So with that, we had to launch. We knew we had to do the redeployment in September. And we had to actually stand up a physical infrastructure and a physical data center and have the redeployed site ready by September. So what we did to accomplish that is we actually stood up an Amazon instance so we could get the teams to actually start the process of meeting with focus groups, understanding content, actually designing, doing a lot of the designing of the website from a layout and design perspective, as well as beginning to work out the content management with workflow and what have you. So it gave us the ability to have multiple work streams work in parallel, meaning we could do a lot of the build out and aesthetic types of work in parallel with actually physically standing up the infrastructure. And at that time, it was actually going to be running at the Savvis Data Center, which is one of the larger data centers in North America. So we launched successfully in September, and we couldn't have done it if we hadn't of actually stood up the test dev environment in the Amazon infrastructure. So, and we received several accolades from standing up Recovery.gov, providing the public the ability to be able to drill down by zip code. At this now, it's a true portal infrastructure leveraging geospatial information and true data analytics on the back end. So a lot of the people you would expect were partners with us as we integrated this, from Microsoft to Esri to SAP. Because literally we had SAP business objects on the back end for some of the data analytics. We had Esri for the geo analytics and what have you. So from September to roughly April, we were in more of a operational state where we kind of worked from a break-fix perspective, meaning when any issues came up, We addressed it when any, let's say, political types of challenges came up with the way information was presented. We would make modifications and continue moving forward. So as we got to around April 2010, we kind of said, well, what if we actually moved Recovery.gov to a cloud construct? What would that actually mean? I mean, because in essence, we did a good job on building a high availability infrastructure, leveraging the physical data center, as well as leveraging edge services. At this time, we were leveraging Level 3 as well as Akamai. So what we did is we actually conducted a feasibility assessment, where we kind of, and with us, we work a lot differently than a lot of other federal agencies, where we don't focus on all of the risks. We focus on the key risks. So we use a risk-based methodology for us to get us to a point of making decisions. So yeah, we did the things that you would normally expect from performance analysis, cost analysis, time, risk, gap analysis, and security analysis. And the outcome of that was clear. It only made sense for us to make a cloud migration. So in essence, we migrated Recovery.gov to the Amazon cloud April 26th at 9:48 p.m. And from initial cloud feasibility assessment to production, it took us 22 days. And with that, we actually saw some savings when you look at the $750,000 over the lifespan of our contract budgets, our budget cycle. But in parallel, we had several, again, other accolades when you look at this actually being the first federal-wide system to move to the cloud. In parallel with that, it was several other firsts. This was one of the first cloud-based infrastructures that actually leveraged Esri, Arc server in the cloud, as well as this turned into the largest SharePoint public-facing infrastructure at its time as well. So I think it's important for us to understand the different layers that we work through. When you look at the key 5 layers, right, from infrastructure, data, visualization, web infrastructure, and social media, these are all of the elements that anyone who's doing any type of data center consolidation have running in their data center. So with us, it's roughly about 50 servers that make up what actually runs Recovery.gov. And with that, from Active Directory, from an authentication authorization perspective, to Amazon's infrastructure as a service, to the security stack, to Esri and SAP business objects, and what have you. I mean, I think everyone can relate to this if you're going through a data center consolidation initiative. These are the types of things that you can actually, you're challenged with now, and in essence, it could probably help you as you look to where you might want to go from a cloud migration perspective. So the outcome was unprecedented results, and we had millions and millions of people hit Recovery.gov. It is one of the largest federal public SharePoint sites ever created. It was, at its time, one of the first federal customers to integrate SharePoint and Arc server for a public website. And then we have 14 of 15 nationally recognized awards. But now quickly, when you look, this is what we've done. And now we have a couple of other things that we're actually working on now when you look at a migration perspective. So we always focused on the internet. And now we are actually focusing more on the intranet and some of the private type of information. So right now we're actually extending some of our Recovery Operations Center capabilities to the public, but in parallel, we're actually migrating our general support system infrastructure to a cloud construct, a true hybrid cloud construct that, in essence, I don't think it's actually been done for real in federal, where we're going to have the right workloads actually run in the right places, meaning we're actually looking at running mail-in collaboration with an application as a service provider, and also running virtual machines from an infrastructure as a service, running that in the Amazon infrastructure, and securing the whole thing between all traffic, including VDI, back to one pane of glass at our data center at 1717 Pennsylvania Avenue. So we're pretty excited about that, and we're working with all of the people you would expect to make that happen. And we're also in pretty good conversations with NIST as well to kind of help with the standards for cloud as federal begins to make those steps forward.
Thank you, Sean. This was a great overview of Recoverygov and the effort that went into moving it into the cloud. Another good example is the application that was put together for the sad events in the Gulf spill, oil spill, and how the disaster needed to be recovered from and handled and managed. So Esri has worked with BP on building this application to allow the different people responding to this disaster understand what is the kind of information that they're seeking, find it as a way to get to the details, and also make sure that everybody is unified when it comes to looking at the data from different responders to different users that are planning for it to others who are taking into account information in the field and trying to collect that information and bring it back for everyone to look at. So the diagram we're looking at right now shows you an example of how that was accomplished. The central database where BP has typically had their operations and their capabilities, which runs on their premises, was intact. It ran the same way it always did. But what we did is we got the updates out of that central database to the database that was running in the cloud. It was basically an enterprise view database that was set up using the ArcGIS for server Amazon machine images. And also on top of that database, there was a range of ArcGIS servers that were running where auto-scaling was applied. And through auto-scaling, elasticity was accomplished. So depending on the type of load that was needed, the type of servers would increase in numbers. And if there was minimal load, the servers would terminate themselves and only a smaller number of them would be running. By publishing both the application as well as the content through web services, different type of users were able to look at the same data. They were able to make decisions, update the data when needed, and as well as utilize it to create more applications and run analysis as needed.
Thanks, Marwa. That was great. So what does the cloud provide? Let's get a little more practical here. We'll go through some value propositions quickly and then talk more about architecture. So you can deploy applications very quickly. You can lower your operating costs, and you can actually speed up the processing that you need to do by running processing in parallel with larger numbers of systems. Everybody knows how hard it is to build a new system. There's a long set of planning steps that are involved, lots of people involved. There's a whole acquisitions model. There's many steps that you need to go through. And in the end, what you get out of that is some equipment, and with that equipment, then you begin to build the software solution. And of course, it's the solution that you really care about. So it's really, in a way, kind of at the end of this long chain is the key part where you begin after quite a bit of many previous steps. So with the cloud, you can skip a lot of that because you can deploy new development environments very quickly, new test environments. If you need to set up a system in a foreign region in Japan or in Europe, for example, you can do that with a few mouse clicks and eventually deploy a new production environment as well. So just a couple more examples. In the aftermath of the tragic earthquake in Haiti, within a matter of days, there was powerful new detailed satellite imagery available. ESRI, working with a number of first responders and government agencies, was able to set up a cloud-based application. It was deployed in just a few hours. And using that, and again, using the elasticity of the cloud, auto-scaling, which we'll talk about, that application was able to be up and running and dealing with a very large load or loads that varied considerably in a very short amount of time. providing tremendous value, and doing that in a way that just isn't really practical in the traditional fashion. The key thing about the cloud and capacity is to think about the requirement for keeping your workloads running but not spending more and having an over-provisioned environment. So, for example, if you look at how many users you're going to need for different amounts of capacity, how much capacity for different amounts of users, you're going to find that you have sometimes over-provision and you waste capacity. Now, if the demand will increase, then you'll be unable to meet the demands. So you're essentially fighting this battle all the time to match the capacity that you have in an on-premises world with the varying loads, and you'll often be, it'll be like a head fake there where the capacity seems to be more is needed, so you buy more. Then the load will go down. You'll essentially have wasted capacity. So this problem is just a continual problem when you're dealing with fast-changing workloads in an increasingly agile environment in which IT has to operate. So the point of this is to try to avoid these both the red waste and also those lines that are too high and you can't meet the requirements. The point of cloud is that you can match your capacity, always staying, just above the line there. So in this case, as your needs grow, you raise your usage of cloud resources, and you can track that very closely and use and pay for only what you need. A couple more quick examples. The USDA had a new program that was about to be launched, and the program manager was given this very difficult task, said, look, we have a brand new program. We need to be able to respond to the food stamp, a new food stamp program, and we need a new system up and running in a matter of weeks that shows people where they can obtain food stamps and redeem them. So faced with that challenge, the program manager looked at the cloud for the solution and looked at Esri's cloud managed capabilities. Using that, and after a very brief investigation, the USDA was able to launch in 3 weeks a website for SNAP. They've set it up with, again, auto-scaling, and unfortunately, because of economic conditions, the usage of food stamps over the last few years has risen to record highs. But in this case, that system has had zero downtime. It's been 100% reliable and was able to be launched extremely quickly and then respond to the changing workloads automatically. After that experience, the USDA has now begun to launch other workloads. For example, this Healthy Access Locator, which is a ESRI-based application that enables various kinds of overlays and maps showing school districts and their efforts to deal with healthy food, as well as the ability to find resources for healthy food in different locales. One of the key value propositions of the cloud is that you can use parallel workloads to increase throughput. GIS and Esri software is actually very well suited to this because many of the problems that you deal with can be broken up into smaller problems and run in parallel. So, for example, on the Amazon Elastic Compute Cloud, which is our compute resources for our Amazon cloud, you can take a job that might take 1 day on 3 machines. You can cut the processing time in half by simply running it on double that number of systems. You can cut the time again in half with another doubling of systems, all the way up to cutting your total processing time down to just a matter of hours by running parallel systems. You can scale, therefore, and dramatically decrease your overall time needs by scaling up the amount of compute capacity that you use. And again, the beauty of this is you're paying essentially by the machine hour, although there are other payment models where you can reserve instances and so forth. But the total cost is the same whether you run on 32 servers for an hour or 1 server for 32 hours. Let's talk a little bit about some of the architectural principles here. Getting data in and out of the cloud, of course, is a critical element of building a cloud-based infrastructure. And there's a variety of techniques that can be used to provide high-speed throughput for your data if you have large data volumes that you need to move. One thing, very simple but very, very practical approach is a service we call the import-export service. In this service, you simply mail us, overnight us. Your FedEx is a very high-speed bandwidth network. A set of hard drives, which they have a manifest file in the root of the hard drive. They need to be formatted in a couple of the industry standard file system formats, whether for Linux or Windows. And then when that hard disk arrives at our data centers, we are able to import that data directly into your S3 buckets or your EBS volumes. We'll talk about those too in a second. And it enables you to do very, very large data transfers and very quickly by simply moving the data to the edge of our high-speed internal networks of the cloud. Another approach is the direct connect approach. Amazon regions are available through private interconnects. So if you have a point of presence for your network, which is adjacent to one of our data center areas, then we work with a number of partners to literally be able to just string a fiber optic cable between your cage and our cage, and you can get 1 gigabit or 10 gigabit interconnects, providing you both complete privacy and security since the data never actually hits the internet, but also very high speed and low latency connections between our cloud and your networks. And finally, we have a number of partners. Aspera is mentioned here, and there are others that specialize in providing software solutions that take advantage of things like UDP streaming, that work around some of the problems with the way TCP networks will slow down. They'll throttle sometimes based on windowing issues. And using these software stacks, you can move data at an incredibly fast rate across the internet and into the cloud. So this is something that's been mentioned several times, but I want to make sure that all of our audience grasps this key distinction between the two fundamental storage services in the Amazon cloud. We have two fundamental services, Simple Storage Service and Elastic Block Storage. Simple Storage Service is a web-style object store. It's not a traditional file system, but rather a very, very high capacity, very high scale storage system that uses HTTP as its protocol and allows you to put and get objects of essentially unlimited numbers of objects and of very, very, very large sizes. The uploads can be done in one bulk upload, or it can be done in segments. So we have the ability to do chunked uploads. And then you can also do range gets so that you can pull parts of objects out using, again, the standard HTTP protocol commands. This S3 automatically scales and shards your data so that if certain parts of the storage system become hot, there's lots of requests, then we're able to scale that out and serve that from multiple servers automatically. So this is a very high speed, very high capacity system that is used for essentially web style content and using web protocols. Elastic Block Storage think of it as like a virtual hard disk in the cloud. There, your EC2 instances can mount and unmount these logical volumes and treat them as traditional file storage. Depending on the type of work you're doing, one or two of these kinds of storage will be suitable. For your less rapidly changing data that is going to be served out through your web servers, S3 is the perfect solution. This also works nicely with our content edge caching service, or CDN. And your EBS volumes are there for the compute power that you're running in the cloud to act as a standard file system, but also to be able to disconnect those. The lifespan of those volumes is not related to the compute volume of the compute instances, so you can keep them there dormant, or you can load them onto one or more machines as you need to. And of course, I mentioned content delivery networks, and that's key to high-speed delivery of large amounts of data. So we have a built-in CDN in the Amazon Web Services Cloud that takes S3 or other content and caches that globally on the basis of a first request up to 26 edge locations. It's extremely easy to use. It's literally a few mouse clicks after you've signed up for the service, and it's highly reliable, highly scalable, and highly available. This is a good example of how we would use ArcGIS on the Amazon cloud. You can use your imagery sets, your vector data sets, and your tile data stored in different locations, or either EBS volumes or for typically S3 for some of the pre-computed tiles, and stream those very rapidly to your users and to the edge network as well. So a typical deployment, a larger deployment, would look something like this. You'd have a set of web servers that are in an auto-scaling group, which means that depending on policies that you set as the CPU load or the I/O bandwidth load varies, the system will automatically increase or decrease the number of servers that are serving that content. Those would be behind a virtual load balancer called an elastic load balancer. The load balancer directs traffic based on different policies that you can set, whether round robin or load based. It also does health checks and maintenance. This enables you to build very high speed, very scalable systems. And behind that, then a database and a set of your vector data set. Here, here's a further illustration now where we're using both the system we described previously, but also the S3 capability, so you have data stored, your more static or precompiled data in the S3 buckets, and CloudFront now is allowing your users to access this data through a high-speed edge caching system. Mara, would you like to add anything to the description of these last couple of slides?
Sure. I'd like to make just a couple of elaborative comments regarding how to set up ArcGIS server and the enterprise geodatabase. It's very easy to do that using the Amazon Machine Images that Esri provides. Using these AMIs, you can launch an instance, and once this instance is up and running, it will have the software already set up, configured, and ready to use. Using this instance that's already running, you can use one of the means that Mark has just mentioned on how to upload your own data, create your own services, upload your own application. And then you will have a machine that is being configured not just with the software, but with also your data and your application. And you can create your own Amazon Machine Images based on that. So next time you launch a new instance, a machine that is running, it will already include your data and your application. You will not need to manually configure it or set it up yourself. Based on this approach, you can apply auto-scaling to ArcGIS server, and it will automatically bring servers that include your data and content, and it will all be running within that environment. Similarly, for the enterprise geodatabase, when you launch an instance from the Amazon Machine Images that Esri provides, you will have it enabled to support spatial analysis, spatial types. It will connect with your server and upload your data to that, create another custom Amazon Machine Image based on that, and you will always have a backup for your data and your database. So it's very easy to set up this environment and get started with it, and it would be really great to learn how you will all approach that.
Great. Well, thanks, Marla. I'd just like to let everyone know that there's been a lot of questions today, but we're going to have a few minutes to address some of those. We've been addressing them also throughout the presentation. If you have more questions or you'd like to look deeper into ESRI applications on AWS, you can learn more at our website, which is aws.amazon.com/federal. And you can contact us there to contact your account manager and ask them the questions that you have on running this ESRI applications. Before we jump into the questions, we have just one more poll just to see whether people are getting a lot out of this webinar. We sort of did that initial question where we were basically saying, what are you hoping to learn? We hope we went through most of those today in detail. You're able to see what we need to do there, and that see how much more likely you are to actually deploy applications on the AWS cloud after this webinar. and then we're going to go into a few questions that are coming up right now. So here's the results from that. And from there, we're going to move into a couple questions. So one of the first ones I'd like to get into is it's really around costs and actually planning for fiscal expenditures. And Sean, if you're willing to take this one, the question is from Pat at the U.S. Fish and Wildlife Service. They say it's difficult to plan fiscal expenditures when it's pay for what you use. How does the USDA basically how do you deal with that, particularly in an era of shrinking funding?
Well, Pat, first off, I used to work for USDA Forest Service for 17 years, so I feel you. So second, I mean, this is the era of opportunity right now. Because you can actually leverage the deficiency in, I'm going to say, IT funding to work in your best interest, because in essence, you can quickly have it authorized, because you can make real cost savings out of current year. So quickly, when you look at cloud services, it's no different than the services that you currently pay for out of your physical infrastructure, whether it be network, storage, servers, or what have you. And then you can even go further when you look at your security infrastructure and how you're paying for your pipes and power and what have you. In essence, you can actually carve off a piece of your current year funding to actually do a proof of concept with an expected outcome of becoming more efficient and true cost savings, meaning focusing on hard savings, not soft savings. When you say, if I do this, what bills can I pay less for, and what bills can potentially go away? In essence, you can quickly do this out of current year funding to actually do a proof of concept, prove that it can actually happen, and then you can begin the migration, start in current year, and then it's going to set up your out years. I hope that answered the question.
Great. Thanks, Sean. Hey, Mark, I was curious, do you want to touch on fixed price reserved instances in the GovCloud region?
Sure. One of the capabilities we have to manage costs is to essentially prepay for a certain level of usage of your EC2 instances. So, for example, if you have a system that you believe will be essentially continually in use, like a core system, you can pay upfront for essentially 100% use, or certain percentage levels below that. We essentially have low, medium, high, and complete. And we have a cost calculator that shows you the break-even points. So based on your estimates of how much a system would be running, you can essentially prepay and get significantly reduced prices, as well as somewhat more mimicking the traditional fixed price model where you essentially buy gear. So we have that as an option. And those reserved instances apply not to particular nodes that you're running or particular instances, but they essentially are an accounting construct that overlays your monthly usage. So if you have 3 or 4 reserved instances and you're running 7 systems, those reserved instances rates will be applied to minimize your monthly bill. So you have some ability to go to a more fixed price style model for EC2 instances.
Great, thanks, Mark. And there have been quite a few sort of cost estimation questions that have come in. If you prefer to do this sort of by yourself or a self-serve method, you can use your search engine of choice and search AWS simple calculator, simple monthly calculator, and you can go there and put in your inputs, and we'll estimate what your monthly bill would be for doing that. Another way, again, is if you go to our webpage at /federal and click Contact Us, that's something that we'll be able to help you with as well in terms of going through. And then this will just be a last question. It's really more of a theme from many people that I'll address to Marwa. Marwa, there's been a lot of questions on licensing in terms of when they're trying to run ESRI applications in the cloud. Many of the customers are unsure, well, how do I take a license that I have, or how do I get a new license for running these types of applications? Could you address that briefly?
Sure. The type of licenses that you can run in your on-premises environment or your virtualized environment apply to the cloud as well. There is no special licensing for running ArcGIS Server in the cloud. It's your typical license. You can use it in any of these environments as you wish. So if you're going to start a server in the Amazon cloud, you can purchase a new license for that or migrate one of your current licenses that are running in your own environment and migrate that to be the license you will run in the Amazon cloud. Regarding how to size the license, the same rules apply. The number of virtual cores that run within the Amazon instance is the same way to estimate how many cores the license will run for. So if you have a license for 4 cores, it would be suitable for a machine that has up to 4 virtual cores.
Well, thanks so much, Marwa. That will wrap up today's presentation. Again, there were many questions we weren't able to get to today, so please reach out and contact us, and we'll also do our best on following up if you did ask a question today with an appropriate answer. I'd like to thank all our presenters today. Thanks, Mark. Thank you, Marwa, and thank you, Sean. And I'd also like to thank everyone for attending today's webinar on ESRI applications in the AWS cloud. Thank you.